Okay, so we're going to be going over simplifying questions, use product and chain rules for derivatives. Okay. So in our first example here, we have our function, and again, this looks like something we'd use quotient rule for, and we could use that for it. But what we want to do is we're going to turn this into a product type question first. So before we derive it, I can rewrite the question to say 3x squared minus 8 times 5x plus 2 to the power of negative 3. Then from there we'll use our product rule. We'll find the derivative of the first one and keep the original, and then we'll add that to the derivative of our second one and keep our first one. Okay? And I put those colors on there because I'm going to try to do it in that order. So like we said, we're going to find the derivative of our first bracket in red. So the derivative of the bracket becomes 2 times 3, so we'll get 6x. The 8 becomes 0. So the derivative of the first bracket is 6x, and the original is written as 5x plus 2 to the power of negative 3. Plus, now we'll write the original of the first bracket in green, 3x squared minus 8, and then we have to derive the second bracket. Now this one, we also have to apply the chain rule to. We bring down our negative 3, so negative 3 multiplied by 5x plus 2 to the power of negative 4, plus we have to derive what's inside that bracket. And the derivative of inside that bracket would be the value of 5. So then we're going to quickly simplify this. This here would become 6x over 5x plus 2 cubed. And then first I'm going to deal with our coefficients. Negative 3 and 5 gives us negative 15. So we could say subtract 15. Okay. Because this is to the power of 1 and it's positive, it would stay on top. 3x squared minus 8. Okay, so we've dealt with the green, negative 3 and the 5. And finally, because this is negative, this would go on the bottom. So we're left with 5x plus 2 minus 4. Okay. Now we could get common denominators, so to add this, but this is essentially the derivative of our function. Okay. We've got our answer. We can go farther into this to simplify. In order to do that, we need common denominators, which means we'd have to multiply. Sorry, this becomes positive on the bottom. Let me check that. I'd have to multiply this fraction by x, 5x plus 2, the top and the bottom. And then from there we could expand and simplify. But this is all I want you to recognize, that we can change a quotient into a product rule question. In our second example, we have a very large product rule, and the question asks us to find the tangent when it's horizontal. Okay? So we're going to derive this function, and then we're going to talk about what it means to find a tangent when it's horizontal. So the derivative f prime x, and hopefully I wrote that above f prime x when I went through this. No, I did not. F prime x. Okay. In this case, it's very similar. We find the derivative of the first, and then we keep the original of the second and the third. Then we keep the original of the first, derive the second, original of the third, and finally original of the first and the second, and then derive the third. Okay? So there's just an extra addition in this question. So f prime x, derivative of our first value, we'll always do the derivatives in purple, we'll keep the greens as the original, is going to be the value of just 3 multiplied by 2x plus 8 times 3x squared plus x plus 1 added to the derivative of the second term is just 2 multiplied by the original of the first, 3x minus 2 times 3x squared plus x plus 1. And then I don't have enough room, so I'm just going to add it on the bottom. Derivative of the third. Now the third one is a little more to derive. This becomes 6x plus 1. And then we multiply it by the original of the first two, 3x minus 2 times 2x plus 8. I really shouldn't have chosen this question to do the horizontal 4. Okay. Well, we have our question here, and we can distribute and then possibly factor to go through it. This will be very complex. Going through the factoring, specifically this value here, we'll probably have to use quadratic formula, especially if we derive. Okay? So the idea here is we have our derivative. We can do some simplification. But what we want to find now is when something is horizontal. When something is horizontal, what is the slope? 0. So what we would do with this question, and we're not going to go through the process because it's going to take a very long time, but we would need to find when f prime x is equal to 0, which means we would set this equation equal to 0 and find for what values of x we get 0. And there may be several values, which means our function may look something like this for all we know. Okay? And all of these would be horizontal points along our function. Okay, so whatever those x values are, we would know we would have horizontal tangents to our original function at that point.